Hey kids, it's Mrs. Banky here, again, or should I say the Wicked Witch of the West. Sometimes when I come out at night, this happens. I can't explain it. No scientific explanation here, but I can't help it. Anyway, today I am going to start part 4 of my video series on naming compounds and writing formulas. In part 1, we focused on binary ionic compounds, which contain just 2 elements, a metal and a nonmetal. And in part 2, I talked about ternary ionic compounds, which contain at least 1 polyatomic ion and 3 or more elements. In part 3, I talked about binary molecular compounds, which contain 2 nonmetals and use prefixes in the name. And today I'm going to focus on acids. Acids really are a special type of ionic compound, and until now, we've been treating hydrogen as that cation, and we said that if hydrogen was present, we would consider it ionic and treat it as an ionic compound. Well, it in fact is an ionic compound. It's made of ions, and it's always hydrogen ion and then another ion. Again, in advanced chemistry, we will talk about organic compounds in depth. We may touch on them a little bit in this series, but I haven't decided that at this point yet. So, acids, by definition here, it says in its simplest form, an inorganic acid is defined as a hydrogen salt dissolved in water. By this definition, a simple inorganic acid exists in the aqueous state. So, let's just put this into normal words that we've been talking about. All right, inorganic acid means that we're talking about typical ionic compounds like we've been dealing with so far. Organic acids take on some different characteristics, and will get discussed more in depth in advanced chemistry, but for the most part, we see what are referred to as inorganic compounds in here, and they are the acids we're going to encounter. Now, it says it's defined as a hydrogen salt. Most ionic compounds are considered salts. We're used to hearing the word salt as, sodium chloride, table salts, so you've heard of that before, Epsom salts. In reality, most ionic compounds are considered salts, and acids in particular are a hydrogen salt, meaning the cation is made of hydrogen, and then the anion is made of either a single element or a polyatomic ion. Okay, so before, when we had formulas, we, let me just engage the pen here. And I will get my little pen, and hopefully it doesn't make me write like a kindergartner this year. This evening is when I'm doing this. So before, if we would have seen HCl like this, we would have just named it hydrogen chloride, not hydrogen monochloride, because we didn't categorize this as a binary molecular compound. So we said that if a compound contained hydrogen, a metal, or ammonium as that first element, that it would be considered ionic. So we would name it hydrogen chloride. HF, hydrogen fluoride. NO3 is the polyatomic ion nitrate. So this is named hydrogen nitrate. HC2H3O2, this polyatomic ion is acetate. So we would call this hydrogen acetate. And ClO4 is perchlorate. So hydrogen perchlorate. Now, if we take any of these substances, and they can exist one of two ways. Some of them will exist as a gas under ordinary and stable conditions, and some of them are more like a salt, something that could be dissolved in water, similar to if you could imagine taking salt and dissolving it in water. So if you take that and actually dissolve it in water, in chemistry, when we want to describe states of matter, for example, if I had some iron 2 oxide, that is a solid at room temperature. So you might include a little S like this. Water, most of the time at room temperature, or not most of the time, but its most common state, is a liquid. So you'd see a little L in parentheses. HCl, hydrogen chloride, is actually a gas at room temperature. But if we dissolve that in water, and you can dissolve solids and liquids and gases in water, it becomes an aqueous solution. So the symbol that we use for aqueous is a little AQ. So when it was just as the salt or the gas, we called it hydrogen chloride. As soon as it dissolves in water, it takes on the properties of an acid, and we then change the name. Now, this is kind of a bummer because, you know, it's been working well up till now. You guys could name these things easy peasy. You were getting the hang of it. And all of a sudden, I throw this curveball at you and say, okay, now if there are the circumstances that are special, then we use a whole different naming scheme, and that's just my witchy ways. You can expect little twists like this to happen throughout the year, but I'll help you. For real, I'll help you. Anyway, HCl, hydrogen chloride, which is what we called it before, is now called hydrochloric acid. Hydrogen fluoride is called hydrofluoric acid. Hydrogen nitrate, if it is dissolved in water, nitric acid. Hydrogen acetate, acetic acid. Hydrogen chlorate is perchloric acid. Oh, I made a mistake. Hydrogen perchlorate is perchloric acid. One thing that I think just we should take notice of, and the next few slides are going to emphasize this, when we have just two elements, it's called a binary acid, two elements, and the way that we name it is it always starts with hydro, and then since the element is chlorine, the root chlor, and it ends in ic, so hydrochloric acid. Here HF is hydrofluoric acid. When the anion portion of the acid ends in ate, it is a polyatomic ion. So you can see this group of elements, each of them is a group of elements. Their names all end in ate. There's no hydro here. So hydro is only reserved for those acids that have just two elements. But the name is nitric acid then. So hydrogen nitrate ends in ate, then the acid name ends in ic. So the anion ending gets dropped and we replace it with ic. Here the anion ending of acetate gets dropped and we replace it with ic. So acetate becomes acetic. And perchlorate, it gets dropped and we have perchloric. So the next several slides are going to review this as well. Note they all have the general formula H. We have hydrogen and then an anion. Whether it's a single element anion or a polyatomic anion, you do see that hydrogen in the front. Now by coincidence, all of these have only one hydrogen, and that just happens to be because hydrogen does have a plus, oh, my pen got disabled. Hydrogen does have a +1 charge, and then all of these anions have -1 charges. So using the crossover rule, it just so happens that by coincidence, all of the examples on this slide have just one hydrogen. Okay, the pep band just started. The final countdown. Not sure if you can hear it. Nothing wrong with a little bit of extra background information. Okay, first type of acid that we're going to look at are the ones that don't contain oxygen, and these are the ones that in class I referred to as binary acids. I am going to change my pen color to match my Wicked Witch of the West hairdo, green. So we refer to these as binary acids. Contain two elements, hydrogen and a nonmetal. If they're not in water, the name is just hydrogen and the name of the anion. So HCl, hydrogen chloride. H2S, hydrogen sulfide. H3N, I am not sure if you can see that or not, but it says H3N. From my view, I have some things here kind of getting in its way. Hydrogen nitride. Now, if it is dissolved in water, what you see is that we use the prefix hydro. Oh, you can even see the green over the green. How wonderful. I wonder if I'm down here somewhere, maybe I can't tell where I am. If you can see the green on the green. All right, just doing a little experiment here. And I know I digress, but I'm very easily entertained and I can't help myself sometimes. So I will check that out in a bit. I'm sorry, back to this. If the acid is dissolved in water, or if the hydrogen compound is dissolved in water, it's an acid. And we use hydro and then the root or the element ic acid. So since this element is chlorine, hydrochloric acid, hydrosulfuric acid, hydronitric acid. Okay, so if there are binary acids, that is when we use hydro, the root, and ending in ic. If there's more than two elements there, we will eliminate the use of the hydro. So those acids that contain oxygen will typically contain hydrogen and a polyatomic ion. Now, like before, when it's not in water, it would just be called hydrogen and the name of the anion. Now, in water, just like any of these substances, they take on acidic properties, so we have to go use a whole different new naming system to name it. What we do is we have the root name, and then if the anion ends in "ite," then the name of the acid, the ending will change from "ite" to "ous." If the anion ends in "ate," the "ate" is dropped in the acid name and it changes to "ic." So I will just put an example up here. So if we have hydrogen ion, and we have NO3, which is nitrate, the name of it, if it's not in water, would be hydrogen nitrate. Now, in water, since it ends in "ate," the hydrogen gets dropped, that gets dropped. We drop the "ate" and add "ic" instead, so it becomes nitric acid. Now, let me take the other one that's kind of like it, nitrite. Hydrogen combining with nitrite, NO2. Now, that's nitrite. I-T-E, nitrite. I'll write it like I did the other one. Hydrogen nitrite. With this, we don't use the word hydrogen in the acid name. The "ite" gets dropped and it gets changed to OUS. So this becomes nitrous acid. So the formula then for nitric acid, since positive and negative is just HNO3, And the formula for nitric acid, I think I said nitric acid. Nitric acid is HNO3. Nitric acid or nitrous acid is HNO2. So we'll look at some more examples on the next slide. Hydrogen. I'm going to change my pen color to complement my hair. Oh, it may give me my pen. Good. Pep band. NO2, nitrite, which is the example that I just did. If it's not dissolved in water, we call it hydrogen nitrite. If it is, it becomes nitric acid. So, again, if the anion name ends in ite, the ite gets dropped, replaced with OUS. And again, there is no use of hydro here like in the other one. So hydro is not used in this case, okay? So hydrogen nitrate, it ends in ATE, that 8 gets dropped, the hydrogen gets dropped and turns to nitric acid if it's dissolved in water. Hydrogen sulfite, SO3, dissolved in water becomes sulfurous, ite, OUS. Hydrogen sulfate, 8, IC. Now, there are probably a lot of clever ways that we can remember this, but one way that I remember it is I say this little saying to myself that says, I ate something and it made me feel ick. Now, you'd probably say icky, but they just open the door and the music is louder. Well, background music. So I ate something and it made me feel ick. I challenge you to come up with a relationship between ite and OUS. I think that we probably could come up with one that I might remember, but you're going to be able to summarize this on your cheat sheet. So at this point in time, you don't need to remember them. Okay, so what I'd like you to do right now is I would like you to pause this, and I would like you to give the formula for the name or the name for the formula. Now, one thing I want to warn you is that if you do not see the little AQ, you would name it in that traditional ionic compound way. Like this would become hydrogen sulfide. However, if there was an aqueous here, this would be hydrosulfuric acid. So, my little children, I challenge you to pause this and give it a shot. I'll be back in a bit to go through the answers with you. Oh, I guess you're back. Okay, let's go through the answers. The first of this, since it's not aqueous, is hydrogen sulfide. This is aqueous, SO3. If I look on my cheat sheet, find out the name of this is sulfite. So this becomes sulfurous acid. Sulfite changes to OUS. All right, HF, we have 2 elements, and that becomes hydrofluoric acid. Here we don't see the little AQ. This group of elements here is hypochlorite, hypochlorite. So, I guess I was wrong. It's a good thing that I have the cheat sheet. So chlorite is ClO3. Chlorate is ClO3. Chlorite is ClO2. Hypochlorite is ClO. So this is chlorite. We just call it hydrogen chloride. Here we see the aqueous. This is iodate, so this becomes, it's not even iodate, it is hypoiodate, and it becomes hypoiodous acid. On the cheat sheet, you will see IO, and it is called hypo. It is called, it has a -1 charge, IO with a -1 charge. It's called hypoiodite. So, ending in ITE, this ends in OUS. Here, no AQ for not dissolved in water. Hydrogen nitrite, NO2 is nitrite. Here, this is sulfate, hydrogen sulfate. Right, results in sulfuric acid. Here, also dissolved in water, we have hydroiodic acid. Here, dissolved in water, this happens to be oxalate, and it is oxalic acid. Acetic acid is the cation is going to be hydrogen, of course, as always with acids, and acetic is referring to the cation or the anion acetate, C2H3O2 with a -1 charge. So the formula for acetic acid is C2H3O2. Including that little AQ there, it indicates it's an acid. We have to say, oh, yep, it is dissolved in water. So some people are tempted to want to go ahead and put this H with the other H's. For consistency, I encourage you not to do that. We're talking about acids. Let's leave that hydrogen cation at the front, like all of the other acids. Nitric acid has a cation H+. Now, since it says nitrous, I know that my anion must end in ITE, so that must be nitrite. Nitrite is NO2 with a -1 charge, so my formula is HNO2 aqueous. Iodic acid is hydrogen ion, and iodate is, oh goodness, iodate is IO3 with a -1 charge, so iodic acid is hydrogen iodate. If it's aqueous, we call it iodic acid. So some more practice problems, if you feel like you still need a little bit of help, pause this, look at this screen for a bit, and in a moment I will just write the answers on here, and you can refer to them. If you have any questions, please feel free to ask, and I'll get you, my pretty, and your little dog too. All right, here are the answers to this page. Boom. There they are. Pause it if you like. Practice some more. Make sure if you have any questions, you sign into Learning Lab. And I'll be more than happy to help you. Even though I might give you a wicked vibe, and it may not seem that I want to help you. I'm having too much fun. Good night.
Very well. I'll bide my time. And as for you, my fine lady, it's true, I can't attend you here and now as I'd like. But just try to stay out of my way. Just try. I'll get you, my pretty, and your little dog.